Hey everyone, I want to do some final chapter one review today to get you ready for your test tomorrow. So with our test tomorrow, here's some of the things that you should be studying. You first off and foremost want to study your chapter one test prep, that test form that you filled out, because your test will look very similar to that tomorrow. You could study your GIM kit, which is going to have some practice questions on there. Alex has some practice questions that you guys have completed, so you can look at explanations on there. And any of your old assignments on Google Classroom will probably be fair game for your chapter one test tomorrow. So what's going to be on the test? All right, we're going to practice all of our skills today, but here's what's going to be on the test. You're going to have GCF and LCM, greatest common factor and least common multiple. You're going to have to write ratios, put ratios in simplest form, ratio tables, rates and unit rates, ordered pairs, which is going to be used with graphing, equivalent ratios, and ratio and rate problems. So these are the skills that we have learned so far this year. So let's practice them. Starting with greatest common factor and least common multiple. If you remember, when we're doing greatest common factor, all you're doing is finding the numbers that multiply together to get to that number. So the factors of 12 are 1, 2, 3, 4, 6, and 12, because 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. I could do the same thing down here for 16. And then once you list your factors, you are just circling or figuring out which one's the greatest number that they have in common. So in this situation between 12 and 16, they share 1, 2, and 4. So out of those, 4 is the greatest common factor. For least common multiple, that's when we skip count. So if I was doing the least common multiple of three numbers, like 8, 4, and 6, I would skip count by 8s, skip count by 4s, skip count by 6s, and then I'm going to see which number comes up first that they have in common. In this case, 24 would be the least common multiple. So let's try a couple on our own. What is the GCF, or greatest common factor, of 16 and 24? You're going to want to find the factors of 16 and then find the factors of 24 and figure out which one is the greatest one that they have in common. Okay, if you did this correctly, you should have listed your factors of 16, which are 1, 2, 4, 8, and 16, and then your factors of 24, and you should see that 8 is the greatest common factor that they have in common. All right, what is the LCM, or least common multiple, of 3 and 5? So you're going to want to skip count here. Okay, if you did this correctly, if you skip count by 3s, you should have 3, 6, 9, 12, 15, keep going. 5, 10, 15, 20 down here for multiples of 5. And you should have seen that right away 15 is the one that pops up first. So 15 is the least common multiple of 3 and 5. The next skill we want to practice here is simplest form. So if I were to get a fraction like 8 over 10, and I wanted to reduce it or put it in simplest form, I have to figure out which factor out of 8 and 10 I could take out in order to make that fraction smaller. Well, I know I can divide 8 by 2 and I can divide 10 by 2, which is going to bring me down to 4 over 5. And if you look here on our fraction bars, you can see that 8 over 10 and 4 over 5 are going to fill the same amount as when you compare them to each other. So another example here, simplest form for 18 over 24. With 18 and 24, I know that 6 can be taken out of 18 and 24, which is going to bring me down to 3 over 4. Now you try one. What's the simplest form of 8 over 12? What number can you take out of 8 and 12 to make it smaller? Well, hopefully you figured out you could take out a 4. So if I did 8 divided by 4, I get 2. 12 divided by 4, I get 3. So the simplest form of 8 twelfths is 2/3. Next, we want to practice writing ratios. So remember that there are 3 different ratio forms. I can write using the word 2, I can use a colon, or I could write it as a fraction. Most of the time we've been using them as fractions. So if I were to get a picture like this, where I have a bunch of different shapes, and I were to want to figure out some ratio statements, here's some of the things you could say. First, you could say the ratio of triangles to circles in this picture is 5 to 4, because there's 5 triangles and 4 circles. The ratio of circles to all shapes is 4 to 10. So if I counted the circles, I get 4, and then if I counted all the shapes all together, I'm going to get 10. So this is a good ratio, except I can make that simpler. So the ratio of circles to all shapes is 4 to 10, but I also could call 4 to 10 2 to 5, because remember, I can divide 4 by 2 and I can divide 10 by 2. So I can make that simpler. So the ratio in this situation of circles to all shapes would be 2 to 5. Okay, use this data table here to figure out this question. What is the ratio of students playing volleyball to the total number of students? All right, if you did this correctly, hopefully you put this in simplest form. you are going to end up with 1 over 3. The way I got there is I had 12 over 36 because there are 12 students who play volleyball and 36 total athletes. So I knew that a 12 would go into 12 and 36. So if I did 12 divided by 12 and 36 divided by 12, I'm going to get down to 1/3, which is our simplest form. The next skill we talked about in class was ratio tables. When you get a table like this, we are looking for patterns. Every time we're looking at ratio tables, we want to find patterns because we know that all of the fractions in a ratio table are going to be equivalent. So in this pattern, I see that from 2 to 12, I know I can go 2 times 6, which means that from 5 to 30 should also be times 6. And then I see some other patterns that happen on the sides. So whatever I do to one side should also happen to the other side, and the number should work out perfectly. And then we were getting ratio tables that had some pieces missing. So if I were to give a ratio table like this comparing dogs to cats, I see that there's 4 dogs for every 6 cats. And then they give me that 12, if I want to figure out 12 cats, right? So I know that 6 times 2 is going to give me 12, and whatever I do to the bottom, I have to do to the top in this case. So 4 times 2 is going to give me 8. So 8 would be filled in right here. And if I wanted to fill in this piece, I could just use that same pattern in order to get to this piece over here, because I know that 4 times 6 is going to give me 24. So in this case, I would do 6 times 6, which would bring me down to 36 over here on the side. And then we know that all 3 of these ratios are equivalent to each other. All right, let's try one on our own. Which number is missing from the ratio table provided? So look for patterns here. So if I bike 6 miles in 30 minutes, how many miles can I bike, or how many minutes am I going to spend biking 18 miles? All right, there's a couple ways you could have solved this here. The answer should have gotten 90. I first could have looked at, okay, I know 6 times 3 is 18, and 30 times 3 is going to give me my answer of 90. Or, that's if I was working side to side. Or I could work up and down. I know that 6 times 5 is 30, so I could have figured out this answer by doing 18 times 5. Both of those answers are going to get you to the answer of 90. So either way you solved it, you should have gotten the right answer. All right, then we got into rates and unit rates. So we know a rate is when you're just comparing two things over a certain amount of time or a certain amount of dollars, right? So 60 miles per 3 hours is going to be a rate. But when I'm talking about a unit rate, I want to take the miles and I want to put them over 1. All right, I want to put that denominator to be 1. So in this case, you see that 60 over 3 turns into 20 over 1. Because if I drive 60 miles in 3 hours, that means I'm really driving 20 miles per hour. In this case, if I'm typing 40 words in 2 minutes, I know that my unit rate is 20 words in 1 minute. All right, we want to keep that denominator at 1. So when we're finding unit rates, we're trying to keep that denominator to 1. So in this case, I have 1 hour, and in this one, I have 1 minute. So let's try one on our own. If Shelby reads 40 pages in 8 days, how many pages does she read per day if she reads the same amount each day? Okay, so you want to set that up, and you want to figure out how to get the denominator to be 1. If you did this correctly, you should have figured it out that it was 5 pages per day. Because if I did 40 divided by 8, I'm going to figure out that that Shelby's going to read 5 pages per day. The next skill is going to be ordered pairs. We used ordered pairs when we were graphing points. So I see that there's a couple dots here. My ordered pairs are 4, 6, and my second ordered pair is 6, 4. Remember that when I'm using ratio tables, for example, this one is seeing how much I charge for every lawn that I mow. So if I mow 1 lawn, that's going to be $12. And I could write it as an ordered pair this way, 1 lawn, $12. And then I could figure out the rest of the ordered pairs from that information, because I know that 2 lawns then would cost me $24, or I would charge $24. So this is going to be what ordered pairs look like with ratio tables. So if you were to find ordered pairs based on information, could you do it? So this example says in football, each field goal made scores 3 points. So if you make 1 field goal, you get 3 points. So list this information as ordered pairs, starting with field goals made compared to the total number of points. I want you to do that for 0, 1, 2, and 3. So in your ordered pairs, your X's should be 0, 1, 2, and 3. I want you to figure out the Y. All right, if you chose the correct answer here, you should have gotten 0, 0, 1, 3, 2, 6, and 3, 9. Because if I make 0 field goals, I'm going to get 0 points. If I make 1, I will get 3 points. If I make 2 field goals, I'll get 6 points. If I make 3 field goals, our team will get 9 points. Then we're going to practice equivalent ratios. Remember, equivalent ratios are just 2 fractions or 2 ratios that are equal in value to each other. So 3 over 4 and 12 over 16 are equivalent because 3 times 4 gives me 12 and 4 times 4 gives me 16. Since I'm doing the same thing to the top and the bottom, we know that it is equivalent. And in this case, I have to find equivalent ratios of boys to girls. So if I had 3 to 5, I could fill in a ratio table with other equivalent ratios. So if I multiplied by 2, I'm going to have 6 over 10. If I multiplied by 3, I'm going to have 9 over 15. So these are all equivalent fractions to each other. So here's your practice problem. Are the following rates equivalent? If you work for 4 hours for $12, and if you work 7 hours and you get $28, are you getting paid the same in both of those situations? Are these rates equivalent? You should have answered no, that they're not, because the first one would work out to be 3 hours or $3 per hour, and the second one would be $4 per hour. So I'm not getting paid the same in both of those situations. Ratio and rate problems. This is the final one that we're going to talk about today. So Sarah can type 60 words in 4 minutes. About how many words would you expect her to type in 10 minutes at this rate? So in this type of problem, you're going to fill in the information with what you have. So I know that she types 60 words in 4 minutes. So I want to figure out 10. Well, in this situation, I don't have an easy pattern to get from 4 to 10, unfortunately. So I need to figure it out another way. So I know that I can do 60 divided by 4 to figure out the unit rate. So if I did 60 divided by 4, I know that she is actually typing 15 words per minute, because she does 4 for 4 minutes, she does 60 words, and she does 15 words per 1 minute. So all I have to do then is take that 15 words per minute, multiply it by 10, because she's going to read for 10 minutes, to figure out how many words total she's going to read in 10 minutes, which is going to be 150 words in this case. All right, final problem here. Try this one out. Jeremy spent $33 on 3 video games. At this rate, how much would 5 video games cost? If you did this one correctly, you should have broken it down and gotten $55 is the total cost. The way I did that was took 33 divided by 3, because I know I wanted to figure out how much he spent on one video game, and then I multiplied that by 5 because I knew he wanted to buy 5 video games. So then 11 times 5 would give us 55. All right, guys, we have our test tomorrow. Please, please, please study. Make sure you're practicing these problems. If you need help, email me today, and then let's get ready for our test tomorrow. Have an awesome rest of your day today.